Assalamu alaikum students. So our today's topic is parametric equations. Now what are parametric equations? Let's look at this example. A baseball is thrown in the air. The function f of t is equal to 40 times t represents the horizontal distance that ball has traveled after t seconds, and the function g of t is equals to negative 16t square plus 48t plus 64 represents the vertical height of the ball after t seconds. So there are two different situations for the same baseball thrown in the air. The first one represents the linear equation, the function which represents the horizontal distance covered by the ball uh, after t seconds. The ball which is thrown from here, the horizontal distance this covered by the ball. Okay, and g of t represents the vertical height of the ball after t seconds. So these are the two different situations for the same ball. This represents the horizontal distance after t seconds. 1 2 3 4 5 seconds the ball covered almost 160 feet horizontal distance, and this equation function represents the height of the ball. It makes a parabola, goes up the maximum height and comes down to the ground in 4 seconds. What if you want to show both the vertical height and the horizontal distance on the same graph? Because we can see they both are the function of t. This is also in 4 seconds and this is also in 4 seconds. What if you want to show these two situations on the same graph? We use the parametric equations where t is a parameter because they both depend on t. The vertical height also depends on t, and the horizontal distance also depends on t. So we can combine them and represent a parametric curve where, let's say, the horizontal represents the horizontal distance is represented by x. So I can write as x equals f of t, and the vertical height of the ball represents, which is given by represented by g of t. Well, let's say y is the function g of t, where t is the parameter because a horizontal distance and the vertical distance, they are not depending on each other, they're depending on t. So t is the parameter, where L will be the parameter interval, and the ordered pair ft, we can say that x and y, because x and y here are f of t and g of t, will represent a parametric curve. You can see it's going to be like this. The baseball thrown from here and it comes down here. Okay, the height and the horizontal distance. The final, when we combine these two, will be end up like a flattened parametric curve. Now this parameter could be anything. It could be radius, it could be angle, it could be anything. Okay, so write a set of parametric equations for the scenario above, then complete the table and sketch the graph. So according to the scenario above, we know that x represents f of t, where f of t is 40 times c. So I can say that x equals 40t, and y equals g of t, where g of t is negative 16t squared plus 48t. So I can write the equation here. Y equals negative 16t squared plus 48t plus 64. Now, in the above scenario, we can see the time is from 0 to 4 seconds. The time is from 0 to 4 seconds. So we have to keep in mind the parametric interval, the t, where t lies between 4 and 0. So what are we going to do is we are going to take all these values from 0 to 4 for t, 0, 1, 2, 3, 4. We will put these t values individually in x and y. We'll find the values, we'll plug it in here, and then we will draw the parametric curve. So when t is 0, we'll plug in this. To find x, we'll use this equation. 40 times t will give you 0, and 40 times 1 will give you 40. 40 times 2 will give you 80. 40 times 3 will give you 120, and 40 times 4 will be 160. To get the y values, we'll plug in the same t values because y is depending on t, the parameter. We'll plug it into this equation. When I plug in 0, this becomes 0, this becomes 0, I end up with 64. So when I plug in 1 into this, I get negative 16 plus 48 plus 64, which gives me 96. When I plug in 2 in this, I also get 96. Use your calculator. When I plug in 3 here, it will end up will give me 64. And when I plug in 4 here, I will end up with 0. So now now we changed the two linear function and the quadratic function. We combined, and we'll end up with a parametric function. It will be also a flattened kind of a curve. So x on the horizontal axis, it starts from 0 to 160. So let's get started. Each block as 10. So this will be 20, 40, 60, 80, 100, 120, 140, and 160. I can see my values are from 0 to 96. Okay, so let's go the same. 20, 40, 60, 80, 90, 100, 80, 100, 120, 140, and 160. Now I'm going to plug in these x and y. They both are they will represent a parametric equation where the parameter is t. So when x is 0, y is 64. When x is 0, x is what? The horizontal distance, and y is the vertical height. Let's plug in the values. When x is 0, y is 64, almost somewhere here. When x is 40, y is 96, almost somewhere here. This is the time t equals 0. We cannot represent t on this coordinate plane. This is t equals 1 second. Now when x is 80, y is 96. When x is 80, y is again 96, the same. This is when the t is 2, and then when x is 120, y is 64. So when x is 120, y is 64, it comes back down here. This is when t is 3, and when x is 160, y is 0, so it comes back down. This is when t equals 4. So this is my parametric curve. You can see, no, it doesn't, it's straight, it's flattened, and then it goes like this. I'm going to use an arrow that this is the direction it follows in t equal. So x, y, they both depend on t. Okay, this is the parametric equation where t is the parameter. Let's do another example. Sketch the curve given by each set of parametric equations over the given interval. Now we can see x is t squared minus 7, y equals 1/2 t over 2 plus 5, where t is from -4 to 4. So what are we going to do is we are going to create a table of values where t is from -4 to 4. So I have t, I have x, and I have y. So where t is from -4 to 4, -4, -3, -2, -1, 0, 1, 2, 3, and 4. I'm going to plug in this -4 into this, I get 9. Here, when I plug in -4 into this, I get 3. When I plug in -3 into this, I get 2. And when I plug in -3 into this function, I get 3.5. I'm going to plug in all the values, and I will have my set of values here. So for -2, I get -3 here, and I get 4 here. For -1, I get -6, 4.5. When it's 0, it's -7 and 5. When it's 1, it is -6 and 5.5. When it's 2, it is -3 and 6. When it's 3, it's 2 and 6.5. When it's 4, it gives me 9 and it gives me 7. So I'm just actually plugging -4 here, gives me 16, -7 gives me 9. When I plug in -4 here, I get -4 divided by 2 is -2 plus 5 is 3. I plug in all these t values to get x and y values, set of values. Now I can graph a parametric curve here. Make sure you show and represent using an arrow that how it moves. Okay, so let's start plugging in 9 and 3 when x is 9. When x is 1, 2, 3, 4, 5, 6, 7, 8, 9, y is 3 here. And when x is 2, y is 3.5. When x is 2, y is 3.5. Okay. And then when x is -3, so you can see my x, I'm not plugging 3 and t, I'm just putting x and y. This is the time t. This t is a parameter. It's not time, it's a parameter. It could be representing anything, okay? It's just a parameter where x and y, but they both represent t as a parameter, okay? So now when x is a -3, my y is 4. When x is -3, y is 4. When x is -6, y is 4.5. When x is -6, y is 4.5. 1, 2, 3, 4, and 4.5. When it's -7, it is 5. When it's -6, again it comes back to -6, it is 5.5. When it's -3, 1, 2, 3, it is 6. When it's -3, it is 6. When it's 2, it is 6.5. So 1, 2, 3, 4, 5, 6, 6.5. And when it is 9, it is 7. 7 is here. Now I'm gonna show using a curve. It's a curve, a horizontal. Okay. Now I'm gonna show these arrows that it moves in this way. Okay. These are parametric curves where x and y, they both depend on a parameter called t. Thank you. I hope you understand the topic. Assalamu alaikum.